All right, here we are at lesson 3.6, which is all about the electron and some important things that we need to know regarding this part of an atom. A few basics at first. Like we said before, the electron is a charged particle that has a charge of -1. It has a spin of 1/2, which we'll talk about that in more detail later on, and very, very, very small mass. Remember way back to lesson 3.3 or 3.4 when I said its mass was so small that it's not even factored into calculations. Super tiny. Electrons behave differently. Well, I will have you watch a video about that. But electrons do have some properties of waves, just like light, and like you can kind of see in this picture. They do have a wavelength, and they move with some sort of wave-like properties. And like we said before, the electrons in an atom are largely responsible for those chemical properties. So bonding and chemical reactions and all sorts of things like that depend very greatly on the electrons that are in an atom. Remember, we talked about how the atom exists, the electron exists around the atom in these different energy levels. So let's talk about those for a minute. Way back in 1913, so over 100 years ago, Niels Bohr, remember he came up with that planetary model of the atom. He said that electrons can only move around in certain allowed energy levels. So those electrons are stuck in specific levels around the nucleus for the most part. But when an atom is given some extra energy, just like you, when you're given some extra energy, it will jump up to a higher energy level. When it does this, that's what we say is called an excited state. So it has some more energy, it jumps up to the next level. It's an excited state. When it loses that energy and jumps back down to its original energy level, that energy is given off in the form of light. So that is basically how light is created. Electrons gain some energy, jump up to a higher energy level. When they drop back down, they give off that energy as light. And then that atom is back. We call it its ground state. So it's either ground state where it normally lives, or it gets more energy and is up in its excited state. We use the letter N to refer to the energy level number. So different energy levels, 1, 2, 3, 4, 5. That's N. So when you see that lowercase n, you know that's referring to the energy level of an electron. As it turns out, scientists discovered later that those electrons don't orbit just like planets, like Bohr thought, which is why we call his model the planetary model. They don't really orbit in those circular orbits. They're in clouds. I spelled it wrong. Circular, not R-A. In those circular orbits, y'all, I'm starting with this word all over again. Whew, it's been one of those days. Circular orbit. There we go. Like a planet. But this model, again, we still use it, especially in our lower level chemistry classes. And it really gave us a lot of good information about the atom and the electrons. So let's go back and talk about that light and exciting the electrons. So when light hits something, so this is the desk, say, or something, right? Some electrons are ejected off the surface. Some places you'll hear the word emitted used. So you can see light is hitting this surface, and those electrons are jumping off, right? Albert Einstein did a lot of studies with this. It's called the photoelectric effect. Um, he predicted that absorptions of photons, which are these little packets of light, gave the energy to excite those electrons and cause them to jump off, right? Electrons. And the energy that these electrons have depends on the frequency of the light. So that's the photoelectric effect just generally. We're not going to spend a whole lot of time on that. I do want to take a minute and come down to this model right here. Let me move this so you can see it. Here we have a hydrogen atom. You see here in its ground state, normal state, that electron is in the first energy level, n equals 1. Right? When it gets some energy added to it, it will jump up to this excited state. You see that electron moved into the energy level 2. And then when it moves back down, it gives off that energy as light. So the light comes off of the electron as it's moving back down. We're going to do a lab on this where you'll see that light that shows the electron is going from its excited state back to the ground state and losing that energy.